Hello everyone and welcome back to another Python tutorial. And this time I'll be talking about my notebook on Kaggle.com based on the League of Legends dataset, which I've looked at in the past and done some support vector machines for. This time I'm just going to be doing some data analysis and visualization with seaborn and matplotlib.pyplot. So take a seat and I'll walk you through it. Alright, so this is some basic stuff, just NumPy and pandas, not that complicated. Let's go down. I import the data and I show some rows from it, or some samples. So I sample 10 so that we get the won games and the lost games. Alright, now we can look at the info. Also, here I make the data frame smaller by 80%. So I moved it down to 2,000 samples instead of 10,000 because I don't want the plotting to take that long when I'm testing it out. So I just take 2,000 for myself and look at them. So here's data.info. Some important variables would be blue wins, blue wards placed, blue wards destroyed, red wards placed, and red wards destroyed. So I'm just going to be looking at the ward difference between both teams. Alright, so here I explain my reasoning. Alright. First, what I do is I actually create a new variable based on the four non-target variables that I described. So it's blue wards placed, blue wards destroyed, red wards placed, and red wards destroyed. And I add up the blue ones and then I take away the red ones so that I get a nice differential here. And here I sample that in this column that I just created. So it's just some normal values. Now I import pyplot and seaborn for my graphing. Alright, let's start with the histogram with a kernel density estimate, or KDE for short. Most people will call them a KDE, but sometimes they'll say the full name, if you're lucky. And here's the graphic that you get when you run this function. So it's from seaborn and it's called distplot, dist standing for distribution. And on the x-axis is the ward difference, which is just ward diff, a variable that I created right here. And then the y-axis is the frequency in decimals. Alright, so basically the black line is the KDE, and it's just kind of like a line plot to show you the what's it called? Distribution of the data. And then the blue bars also help you see the distribution, and that's called the histogram. But the black one is the KDE. So you can see that the data, it kind of goes up and it gathers in the middle and then it goes down. And that's kind of like a normal distribution. That's what you'd call it in statistics. Although there is a little bit of a error here near the 0 value, or the mean. You can see that there's two little bumps downwards, and I'm not really sure why. But I mean, it seems that in a lot of the games, the ward difference is either over 13 or gathered around 0. Mostly gathered around 0, because I guess both teams in the same rank will have similar vision scores. And my goal here for data visualization is to show the correlation between the ward difference and the actual game outcome. Alright, so there's your distribution. Not much to talk about, except for these little bumps here, which we'll go back to later. Alright, so now for the swarm plot. Swarm plot is kind of like a population pyramid. That's how you can imagine it, I guess. But it does look pretty similar to the data if you flip it sideways and then center all of these. Alright, so this still shows the distribution of the ward difference, but this time we add another variable, the game outcome, whether we won or lost. So winning in this case will be for the blue team, and then losing will be for the red team. And losing means that the red team won. So here's red and here's blue. And of course it's swarm plot. Pretty simple. But what we want to see is these little protrusions here. You can see above and below this like mean area near 0. So these are actually the same areas that we saw as bumps in the histogram, but this time because you like did some translation, it's actually more like it's going outwards like you see here. Alright, so what does this tell us? Well, we can see that let's just look at the area below. So we can see that for the lost games, the ward difference is almost around like -25. So that tells us that the less vision score you have, the more likely you are to lose the game. And then you have to compare it to the blue's negative area. And you can see here, this is a lot skinnier than this. And of course, it's thicker on the extremes, because like the lower your vision score is compared to the enemy, the more likely you are to lose. And so you see that it gets pretty thin down here, although there are some outliers like on the very outskirts here. But it's mostly this main bump you have to pay attention to for both sides. And then above you can see a similar phenomenon where the higher you get on the winning side in the positive direction, the thicker it gets actually. And here it just gets skinnier and skinnier. And of course you might not be able to tell, but this mass above the center is actually a lot larger than the losing teams. Or when you lose. It's a lot larger than when you lose. Alright. Now let's look at the box plot. So box plot basically just shows your distribution, except it's all in like this tiny area. So you can see here. And this is like a large percentage of the entire data, as it is for the one area. Alright, so you can see that the blue stuff is actually a lot higher up than the games where red wins. And you can tell because the bottom of this box plot is actually higher on the one side than the lost side. So you can see the difference between this black line and this black line. But the higher black line are about the same, I'd say. And then this middle area is also higher for the blue than for the red. And not much to talk about here because the box plot isn't actually that exciting. Now let's look at the violin plot, and you can see that all of these are quite similar. And that's because they all show like the bivariate analysis of the data. And bivariate meaning there's two variables that you're looking at when you visualize it. Alright, so we can see a similar phenomenon as we saw in the swarm plot. And box plot actually takes away a lot of the details, which is why I don't really enjoy it that much. But you can see that the positive part, the positive relative extreme for the one side is actually a lot thicker than it is for the lost side. Because when you have a higher vision score, you're not likely to actually lose. And then for this negative area, we can see that it actually goes a lot lower, but that's not much of a big deal compared to the blue winning side. And you can see that like this is a bit more plump than this. This losing part is actually a lot more plump than the winning part. So all of this analysis kind of just shows that the more you ward and control vision, the more likely you are to win. And that was my data visualization for univariate analysis, basically the histogram, and bivariate analysis, the swarm plot, the box plot, and the violin plot. Thank you guys for watching. Hope you guys learned something new, and see you guys next time.